Hello everyone, this is IT641 Red Team and this is Sprint 4 presentation. We started with Sprint 4 planning in which we have multiple scrums under our Sprint 4 planning and the tasks are assigned to all members of the group based on their areas of expert and also we have the estimated time and the actual time it took individuals to get the task done. And also we developed a lessons that was learned from the previous sprint which was sprint 2 and the sprint 3 and we kind of like used the knowledge and so what we learned from the previous sprint to develop ourselves and to help us improve on what we did on sprint 4. And the screenshot on the screen right now is the SQL2 queries with stored procedures and user defined function that actually create that shows the employee number and so this is just like a single user defined function that we have out of many that we wrote for the previous sprint. And also the same thing we have the we did the 60 queries for the previous sprint and so this is just one of the screenshots that we got from the previous sprint. So this is the pivot that we did in Excel and we have the screenshot here that shows the information of the branch and the numbers of employees and the total salary, and this was actually designed in such a way that you can easily do some form of a drag and drop and so you can easily generate this information. And also so we make sure that all the group members have MySQL installed on their system, so this is just like a confirmation that each members of the group have MySQL installed on their system. And also we have our previous data model that we have for sprint 3, so that has the inquiry category, that has the inquiry table, the assigned inquiry and inquiry resolution. But for these sprint 4, so we've been able to like work on it and have a better data model that fits well with our fuzzy logic. So this is the information, the data model that we have of our sprint 4. So we have the inquiry, we have the inquiry category, we have inquiry action, and then we have order inquiry. We have the customer, we have the orders, we have the order line, we have the order inquiry action. So all the tables that we have here, they're kind of like related to inquiry. So these are pretty much all the tables that we have that are related to our inquiry database. And also from the database we were able to generate this data model. So when we ran the our query, so we populated the data, so this is the data model that we were able to generate from the database. So as you can see, it's kind of like linked to each other, so which means that so the foreign key and the primary key are working accordingly. And so we also have the populated mock data for local expansion and tested. So we populated the data in such a way that to make sure that the data actually works well inside the table that we have been able to create. So and so that our fuzzy logic can work well, so we kind of like use that approach in designing our attributes. So we kind of like come up with the numbers of follow-up, and the numbers of follow-up is the numbers of time the customer calls to follow up his inquiry. So we think we're gonna need that as one of our fuzzy attributes, so we make sure that we have it in our inquiry table. And at the same time we have the total time. So as you can see right now, so the two last column that we have on the screen, the total time and the numbers of follow-up, the two major fuzzy attribute that we have. So we have them in our inquiry table. And also, in order to make sure that our data that we populated and our database is working efficiently, so we try to run a query on it. And so the screenshot that is on the screen right now shows that the inquiry database is working efficiently, and so the results shows that it's working fine. So I'm gonna be talking about a fuzzy local database development now. So our major objective for fuzzy database development is actually to measure the customer satisfaction, which is actually what we want to derive from our fuzzy database. So, and in order to determine the customer satisfaction, two things are very important, which is actually the total time. The total time is actually the difference between the inquiry start time and the inquiry end time. So, which is actually the time a resolution is being given to an inquiry. And also we have the number of follow-ups, so which actually determines the number of time the customer calls or probably like email, so the number of follow-up email before an inquiry is resolved. So, and in order to determine our uh, in order to and in order to determine the customer satisfaction from our fuzzy database, so we were able to come up with the fuzzy categories in which we have the poor, the average, and excellent. So, and also we made the decision rules and the membership value set in which we have the total time and the number of follow-ups, which are our two major attributes that we have. And we have the decision that was actually made uh, based on the total time categories and the number of follow-ups categories that we have. So if we have a poor for the total time and we have a poor for the number of follow-ups, then it means that the customer is not satisfied. So at the same time, if we have a poor for the total time and we have an average for the number of follow-ups, so the customer is not satisfied based on our assumption. And if we have a poor and excellent as a number of follow-up, so the decision is that there is no response, that we don't know what action that might be taken by the customer. So, but in the case that we have an average as a total time, which is actually the difference between um, the inquiry start time and the end time, and the number of follow up, like, and which if it is excellent, so it means that the customer is satisfied. And the membership set that we have is just pretty much two. We have the 101 and the 102. But in order to accomplish our goal, so we were able to come up with the trapezoidal strategy in which we have the membership set and we have the attribute name. We have the fuzzy name, and we have the range that we kind of like set that, okay, um, the total time for resolution, if it's between 0 to 30, if the total time for resolution is between 0 to 30, so that means it's excellent. So if it's from 25 to 60, so that is average. And if it's 55 to 120, so that is poor. So we kind of like do that based on the different membership sets that we have. And then we have the membership A, the membership B, the membership C, and the membership D, which was actually the result that we got from our trapezoidal strategy. And at the same time, we have the triangle strategy, which is pretty much the same with the trapezoidal that we have, but it's different because we have it as A, B, and C, and but the fuzzy attribute still remain the same. We have the range from low to high, so which with the timing is 0 to 30 is excellent, 25 to 60 is average, 55 to 120 is poor. So, and also we kind of like revise our OS3 master data model. And we also come up with the data dictionary for inquiry and the related tables based on the current inquiry tables that we have. And also we have the five queries to link use cases to other teams. So, and the five queries are check how many customers who inquired about a product have received a promotion, and also to check how many customers have inquired about a product and paid by credit card for that product, and also to list all the customers who have inquired and bought a product, and to list all the employees working with vendors and also with inquiries, and also to list how many employees are handling inquiries in each branch. And the issues and the challenges that we faced when interacting with other teams was that it was difficult to get each team's data dictionary added to master data dictionary document. And also, the project managers have not yet come with a data governance document or a master project scope document. And also, the teams haven't decided on which fuzzy attributes are getting added in the next step of the project. So the master data model needs to be revised and the tables should be colored according to the ownership of the group. So our the team's plan to collect data to expand our S3 master database is to list the tables for the group assignment and also to create the tables according to the instructions, and to list the attributes for the tables and their data types, and also to create mock data from the internet using data types and the columns. So that's the end for the sprint 4. Thank you.